Hello everybody, I'm Marco Dambros, and today we are going to see how to build a Bezier curves in Bifrost with a De Castillo algorithm. And to do so, we are going to see how to use the while node in Bifrost and even the lerp. So the way that the De Castillo works is very simple. Is going to be a recursive function then is going to iterate the lerp between segment. So uh, the way that it works is just like if we have, let's say, 4 points, P0, P1, P2, P3. So which means like we have three segments. We are going to lerp, so linear interpolate between the segment. And we are going to build to find the three points, A, B, C. We're going to iterate these 3 points, is A, B, C, D, E, find the new segment, and from that we're going to find the last point. And this is going to be the point that we're going to draw and build up our curve from. So just to sum it up, if we have like all different points, P3, we are going to lerp between these points multiple times until we don't find just a single point. Here you go. So let's start to do it. Well, let's start to building just a line, a straight line. So a degree 1 and lerp between the points and draw the line. So uh, let's build to transform and our Bifrost node. We need our inputs. So let's create a value node, matrix, and array. So this is going to be our input in transform. There you go. Let's go to connect this node. So transform, and we can have our starting setup. Word matrix. It's going to be in transform. Word matrix, second transform. Here you go. Now that we have everything, we can start to build our line. We don't need the output at the moment. Let's get the first things. Let's create a matrix, decompose the matrix. So matrix to SRT. Now that we decompose it, we can get the value, so get from array. In this particular case, because we just have two elements, you can use even first in array and last in array. So connect and connect. This is going to be our first value. Let's create the lerp. It's going to be first, second. This is our pointing space and our u value. I use the clamp just for just because I'm comfortable with that, but you don't need it. It's just the fraction itself. It's what you need. We actually, so now we can find the point, the famous A in this case. So we just need to draw it so we can visualize. Construct points. How you can see the construct points require an array. So if you plug, you're gonna have an error. Right click, flatten, and now you can connect it. Construct scope, scope, point scope. Here you go. And the terminal, so we can draw our points. 0.1, enter. Okay, and this is going to be our draw side. You can see that the dot here, and when we move it, this is going to lerp between one point and the other. Perfect. And that is our actually, let's see how to draw the line with the sample. So the example that I show you is built by sample. So we can just build a sequence of array, for example, 11 steps, 0.1, connect to here. Here you go. We sample the line and we can draw with all the points. Of course, this is like a straight line. To literally create a line, we can construct the strands, connect, and connect to the diagnostic. Here you go. And we have a curve. Let me show you how to build like to get some color for the curve. So we need to set trained shapes. So we can visualize, run connection, connect the strands. This is going to be a line or a ribbon, so we want to have very, very thin. Nothing is a shape, so we can set a geoproperty. In our case, the property we want to set is color. This is going to be float 3 and float 3. And now we can give the color, let's say red. Let's connect. Oh, we don't need this one actually. And let's connect it. And we have our red line. We can even add a little bit of, make it a little bit bigger. This is good. Here you go. Amazing. Now then we draw, or we cannot do that. Now then we draw a straight line between 2 points. Let's add an extra point and interpolate between all the points in our system. So this is going to be the new transfer, as usual, what matrix to our system. How we can approach this problem? What we want to do now is we want to actually, let's separate this one here. Here we go. We want to link this segment with this segment and so on. And if you see how this goes, 0, 1, 2, we want to link 0, 1, 1, 2, and if we have a 3, 2, 3, and so on. So we want to create two lists. One represents my first block of points, 0, 1, 2, 3. And the second one, the second point. So it's going to be 1, 2, 3, 4, until we have n minus 1 linked to n. Now we want to do this one. The way that we can do it is get the array size. This array size is our n. We want to subtract and remove 1. So we can create our n minus 1. And now with the slice array, we can build two different arrays. One that starts from 0 to n minus 1. The second one is going to start to 1 and is going to finish to n, 1 to n. Now then we have these two arrays. We can just simple connect the result to our system. So let's remove the get from array. Here we go. And we have our segment. And when we move it, you can see we are interpolate between these blocks of segments. And I just going to draw manually just to show you. We can actually, let's use the first in array. If we manually hard-coded build the second lerp, we can see the final result. In this case, we have 3 points, so in theory, we just need to have only 2 lerps. So lerp, first point, second point, and the fraction, of course, need to be the same. Let's construct point. We can actually connect to the here. There you go. If you see, we have a point there. And that is where we're going to draw our line. So if you see, it's going to there, to there. Awesome. So now that we have all the system, let's actually remove this one because we don't want it. This is the system, so this array, that is good, and there you go. So that is the base of our system. And like we mentioned before, we want to iterate until we don't want to iterate on lerps until we don't find just 2 points. So we can or copy and paste, or we can even create a compound, basic lerp, and now we can create a do while. Inside do while, we want to we want to get some points in points. And in this case, it's going to be P0, P1, P2, P3. If you want to see the, and let's connect it. So we have our inputs, then our points, and our output that are in the interpolation. So this is going to be our out points. So if you remember when I explained the lerp, the decay algorithm, we need to iterate and between these between the lerps, and for every iteration we are going to remove 1 point on our system until we don't find just one, and that is the condition that we want. We want, like I say, iterate out points is going to become our input points for every iteration. And now we want to get the array size. Actually, let's do like this because I don't like the. You can have like a two array size. I think it make absolutely sense. It's not like a huge deal. I do like to have all the algorithm here. Here you go. So we can. This one is going to be. This is going to be here. This is going to be here. This is going to be here. And we don't need this one there. And that is our output. So like I said, we want to have our array sites and we want to check how many points do we have. If we have more than 2 points, we want to iterate again. So this condition need to be true. This is the way that do while works. The do while require an exit condition. And this exit condition is going to be how many points do we have inside the system. So when we say that, when we find that we don't have any more 2 points, so greater than, it's mean 3 is going to be the last one going through. The second, when the number of arrays become 2, so DAE, this become false, and we are able to do our last loop before leaving. So now that we have all the system, these are iterate until we don't have just 1 point. So one thing that we can add it is just get the first array. It's not necessary, but I do like to go to output just a single value and not an array. And now we have our out point. Here we go. And we can connect this out point to the construction point here. Okay, you can see the single point. And actually, let's to input. Let's create another input, and we want to go out with a fraction as well. This actually is our u value. So we can put it there and connect. So if you see, we can find every point on our curve. And actually, if that is the only thing you are interested to, you can just output out point, and you can attach anything on your Bifrost node, and you already have a point that follow the path. So now that we have all these elements, we want to draw the curve and we want to sample out. These are two reasons. Well, one, because we want to draw, but the other reason, you can do some operation. For example, compute the length of the curve. The length of the curve is working by sample it and get the length of every segment, then you sample it. So let's cut 1 second the do while, create an iterate node. Inside our iteration node, we want to have our inputs point. Our u value is actually compute here. Let's compute a u value. So instead to use now the clamp, we want to get the sample. So our sample is going to be our max iteration. So we can max iteration go output, Let's call it sample because I do prefer call it samples. Let's start, for example, with 10 sample. This one is going to be here. So we are going to translate this integer in float. Max iteration current. We want to remove subtract 1 to our max iteration. And divide our iteration with our max iteration. This result is actually our u value. Now that we iterate for every sample and find a point in a curve, we need to output this point and set this one as a iteration target. So when we have our iterate node, this is gonna be a list of points, and we can connect directly to our points and construct stand. Here you go. If you can see, this is a curve. And actually, this is already dynamic. So if you want, you can create a locator, a new transform, word matrix, connect. Of course, it's going to be in the same position. Let's move it here away. Here you go. So you have a curve, and every time you're adding every new transform is going to become longer and longer. So let's increase a little bit the sample. They're good, but why not? If you want, we can have 20. It's slightly better. So like I say, because we iterate every segment, and we can compute every segment, we can use that steps to compute the length of our curve. The way that it works, we just need to subtract our position, right? Actually position with our previous one. So we want to go out with the act position. This actually position is become our input previous position, and we are going to cycle our actual position and previous position. One thing that need is the initialization. So the first point we want to find is the first in array, and this is going to be our first previous position. There you go. And now we can actually go out. So this is a vector. Is the differences between the previous position and actual position. So now we want to find the length of this vector, and that is our output. One thing we want to do, we want to set this one as iteration target. The reason why so if we want to compute actually the length, we can even just sum all these lengths. So we can just add an add node and sum for every iteration. It's going to be the same. The reason why I like to go out to output the array is because it can be like interesting to have it as an output as well. This array represents the length for every segment. So if you want to output it, you can have list an array of segment length. So you can find for each different segment, what is the length. If you want to find the total length, we can use the node sum array. In this way, we can just rename in length. There you go. We can just sum all these arrays, and the sum of this one is going to become our total length. Let's try out, because I know that you don't trust me, so you want to see if I'm right. So get the length first. And actually, let's even get the segment length so I can show you. So segment length, there's something here, for example. Segment here. So if you can see, so we can see then the length of our curve is 16, and the segment number 8 is 0.8. If I change, for example, sample to 10, Now it's become 2. If you want to have even the proof, then the value are correct, we can put all the node as 0. We can get just 1 and set to 5. If you can see, the total length is 5. And if we move, like, for example, the segment number 2, or even the 3 as well, we every single segment is increasing. Cool. And that's it. That's it for today. Thank you very much to watch this video. See you next time, Marco.